In Activity 1, students learn that force must be applied to an object to get the object to move. What happens when force is applied to an object, but the object does not move? Is it possible to be working hard and yet hardly working at all? Most people use the word work to describe an activity that requires mental or physical activity. In science, work is done only when a force is applied to an object and the object moves a measurable distance. If the object does not move, then no work has been accomplished. The focus of this inquiry is, what is work and how can it be measured? In Activity 2, students learn that work is accomplished when a force is applied to an object and the object moves. This activity will take about 30 minutes. The vocabulary introduced in this activity is machine and work. For this activity, you will need from the kit plastic rings, push-pull meters, and string. You will also need to supply a medium-sized paperback book, which you probably already have prepped from Activity 1, an 8.5 by 11 sheet of white paper, a pair of blunt-tip scissors, a ruler, a sneaker or a shoe with ties, and Activity Sheet 1, Part B, and Activity Sheet 2, Parts A and B. The activity begins with the teacher placing the word work on the board and discussing with the students their definition of what they think work is. Their definition is very different usually than the scientific definition for work. You want the students to have the scientific definition of work. So have the students break up into several groups of 3 or 4. Have them move to a substantial wall in your classroom, one that preferably is a concrete wall. Have them put both hands up against the wall and push as hard as they can as you slowly count to 30. When they finish, you want to discuss with the students what they felt. Were they tired? What kind of exertion had to be done? Did they apply force to the wall? How? Did the wall move when they pushed against it? Then ask them how they can be tired if there hasn't been any work done. We want the students to understand that there are 3 very important things that are necessary for work to be accomplished: an object, force applied to an object, and motion. The object moves a distance. They'll then go to Activity Sheet to answer number 1. The amount of work is calculated based on the amount of force applied and the distance the object is moved. Remember in Activity 1, when we move the book, we check the force to see how much force was used to lift the book different distances. Johanna, which one of those did we do the most work?
Well, we consider that the amount of effort used to lift the book was the same, but we moved it a greater distance. Therefore, more work was being done because it covered greater distance.
Students will work in teams of 2 to use the push-pull meter to measure the force needed to move a pair of scissors, a book, and a shoe from the floor to the desktop. Johanna, we're going to try it just from our desktop for 12 inches, and we're going to measure the force. So let's see how much force it's going to take to move the scissors 12 inches. And if you'll read that, please.
I'll hold this up. Okay, you pull it up. We're going to use this ruler to kind of go across because we want to measure from the top of the ring. So that's about a half of a unit right there.
Thank you. Let's try the book.
Okay.
Let me get it in the center.
Okay.
There we go.
All right. And put the ruler across here, and that is about 2.5 units.
Okay, let's try moving the shoe.
Okay.
Okay, let's measure that.
Let's see, you're going to have to turn this around so I can read the...
Thank you.
All right, and that is about 4.5 units.
Okay, and what kind of force was applied to lift each one of these objects?
The force that was used to lift each object was a pull.
And how far did you move each object?
We moved each object just 12 inches.
And so in which case do you think the most work was accomplished?
I think most work that was accomplished was lifting the shoe, because even though we lifted it, all three objects the same distance, the shoe was heavier.
First, students learned that moving the same object greater distances used more work. Then they discovered that different objects moved the same distance can require different amounts of work. The heavier the object and the greater the distance, the more work is accomplished. The final step in this lesson is for the teacher to introduce the word machine on the board and ask them what is a machine. How do machines help us do work? Have the students list different machines that they're familiar with and that they like. Give them the 8.5 by 11 sheet of white paper and ask them to draw a machine and label it. Technical drawings are really good assessment tools for the teacher. At the end of the activity, collect the push-pull meters and store them for activity 3.
You might want to check to see if the rubber bands are still taut. If they are not, you might want to consider exchanging the rubber bands for a fresh one.
When you complete activity 2, you may choose to read pages 3 through 5 in the Delta Science Reader.